and welcome back. In this video, we'll be discussing about array indexing and slicing of two-dimensional arrays in Numpy. So let's begin. As you can see, I've already imported the Numpy library into our code. So now let us quickly create a two-dimensional array. And for that, I'm going to type np.arrange, and maybe I want 50 elements starting from 0 to 50. And I'm going to copy this into an array variable arr2d and run the cell. And let's see what is inside arr2d. And we have a one-dimensional array with 50 elements from 0 to 49. Let's quickly give this a shape and transform this into a two-dimensional array by arr2d dot reshape. Let us reshape this into 5,10 since we have 50 elements. So after doing that, we get a two-dimensional array with 5 rows and 10 columns. Cool. This can also be done in just a single step by typing arr2d equal to np.arrange from 0 to 50, then dot reshape this into 5,10, and we get the exact same array, which is this. So similar to that of elements inside an array, the rows and columns inside an array also have index. For example, the first row, which is this, has an index of 0. The second row has an index of 1, and so on. Similar to that, the first column, which is this, has an index of 0. This is 1, this is 2, this is 3, and etc. And in order to access a particular element from a two-dimensional array, we need to know the index of that particular element. For example, 0 lies in the 0th row and the 0th column. So obviously the index of the element of this particular element 0 is 0, 0. And in the case of 1 lies in the 0th row and first column. So the index of 1 is 0, 1. In case of 2 lies in the 0th row and first column. So it is 0, 1. It's always row, column. Fine. Similarly, let's take example of maybe 35. So 35 is in the row with index 0, 1, 2, 3. So 35 lies in the row with index 3 and column with index 0, 1, 2, 3, 4, 5. So the index of 35 is 3, 5. Perfect. Now let us just note down the index of 35, which was 3, 5. Right. Now, in order to access 35, I will have to provide this index somewhere, right? And in order to do that, I'll have to type arr2d square bracket, and then inside that provide the index of the row, which is 3, comma, index of the column, which is 5, and run the cell, and we get that particular element. Awesome. Now let's try the same with a different element. For example, I'm going to choose 28. Okay. So first check which row does 28 belong to. So 28 is in 0, 1, 2. 28 is in the row with index 2. So 2, comma, the column is the 8th with the index 8. Okay, so 2, 8. Perfect. And let's access it by typing the variable name of the array arr2d, then a square bracket. First specify the row index, which is 2, then the column index, which is 8. Run the cell and we get 28. Awesome. We can actually do the same with a different approach, which is by typing arr2d, then providing 2 separate square bracket for row and column separately, and providing the row index in the first square bracket, and then providing the index of the column in the second square bracket. Run the cell and we get 28 as the output. So that was about selecting a particular element from the array. What if I want a series of elements or a range of elements from an array? For example, let's visualize what is inside arr2d. So this is our matrix. So I'm going to type the array name arr2d and then a square bracket in order to access the elements. And then I type a comma. So now I want you guys to remember, anything that comes before the comma belongs to the row, and anything that comes after the comma belongs to the columns. Fine. What if I type a single colon here? And this colon belongs to the row. Okay. and after the comma I'm putting a colon again, and this colon belongs to the column. Okay, so I'm gonna select maybe rows from the 0th index. Okay, fine. So the start index is 0, start index of rows is 0, so this row is selected as the first row which has the index 0. Okay, and up until which row do I want? Maybe I want up until this. Okay, so the index of this row is 0, 1, 2, 3. So in order to access rows up until the index 3, I will have to specify 3 plus 1, 4 as the stop index, because stop index is not included. Fine. And now let us run the cell and see what happens. Yes, we have a slice of the original array with the mentioned row number and column index, that is from the 0th row up until the row with index 3. Cool. Now let us see what happens if I specify the column parameters. For example, maybe I want to select columns from the beginning itself. So the first column is selected, so the index of the first column is 0, so I'm going to give that, and start index is 0, stop index maybe I want up until 6, so 0, 1, 2, 3, 4, 5, 6. So the index of this particular column is 6, so I will have to provide 6 plus 1, 7 as the stop index, because stop index is not included, and run the cell, and I will get the common area between these two selections as this. Let us try one more example. What if I want 6, 7, 16 and 17 as the output? So the elements we want as 6, 7, 16 and 17. So the steps I want you guys to follow is, first provide the array name, which is AR2D, then a square bracket, then a comma, then a colon to the left and right side of the comma, with the left side colon representing the row and right side colon representing columns. Okay, first check the row details of the first element. So 6 is the first element. The row details of the first element is 6 belong to the row with index 0. Okay, then provide 0 as the start index, and then check the row details of the last element, which is 17. So 17 belong to the row with index 1, right? So the stop index is the index 1, so I will have to provide 1 plus 1, which is 2, because stop index is not included. And now let us check the column details of the first element. So 6 belong to the column with index 0, 1, 2, 3, 4, 5, 6. So I'm going to provide 6 as the start index, and regarding the stop index of column, which is the column details of the last element 17, and 17 belong to the column 7, so I will have to provide 7 plus 1, because step index is not included. So 7 plus 1, which is 8, and let us now run the cell and see if we get the desired output. And yes, we have the output 6, 7, 16 and 17. Perfect. I want you guys to try a different example and try if you can get the desired output. For example, go ahead and try to access 23, 24, 25, 33, 34 and 35. So that's all for this video. I'll see you in the next video. Bye.